Welcome to Dr. Jed's continuing calculus video series. Today's lesson is section 5.7 from Rogowski. There's a title in the book, but what it really translates to is harder integrals. So first, we're going to take a little refresher on some antiderivatives that are a little bit more obscure, and then we'll do examples. Lots of examples. Some will be U substitution, some will be more direct. So here's the integrals. These three are inverse trig. There are 6 inverse trig functions, but the inverse cosecant is actually fairly similar to this. The inverse cosine is very similar to that. There's a minus sign difference. And the inverse cotangent is also not really that critical. So these are the three we'll tend to use. There are these two also. This one we've seen before. The integral of 1 over x dx is the natural log of x, or if it's negative, it's absolute log of absolute value of x. The integral of b to the x. Now you can write b to the x as e to the x times natural log of b by using special rules of exponentials. And if you do that, and you use our rule for e to the x, you get to this. So this is not really a new rule, it's just an application of an old rule. So let's take a quick look at one of these, and then do some harder ones. I want to integrate from 0 to 1 over 1 plus x squared dx. So looking over there, it is the inverse tangent of x evaluated from 0 up to 1. This is not bad because we can just plug those in. It gets harder when this no longer looks like what we want. So we have inverse tangent of 1 minus the inverse tangent of 0. Might have to get your calculator out. Hopefully you remember some of it. This is pi over 4 minus 0 or pi over 4. Let's try a harder one. This 1 over 7x plus 1, well, you have to figure out what the right substitution is. There's no form that looks exactly like this. But there is a substitution that works. We can let u be the entire bottom. Why? Because the key to a u substitution is that the du is around. So u equals 7x plus 1. Du, the derivative of that is 7 dx. Do we have that 7? Well, there's a 7 down here, but it's not where we want it. We want it on top. With numbers, we can just add the number in. We'll multiply the number in. So let's make that 7. And then, because we don't want to change anything, we'll also divide by 7. This is how we do a u substitution. If there's something missing, multiply it on and divide it out. And hopefully you can balance it. So this is our du. There's u. This is 1 over 7 times 1 over u du. The 1 over u is going to integrate as the natural log. The 1 over 7 is a number. We can pull it out of the integral. So we get 1/7. The natural log of the absolute value of u. It's an indefinite integral, so it's plus c. If it were not, we'd evaluate at the top and the bottom. Now that's not done because we started with the x's. We better end up with x's. But u is 7x plus 1. So there is our answer. Let's do another. Hopefully that one made sense. This one might make some sense too. On the bottom we have square root of 1 minus 4x squared. Now if you think about this, there was one we had, 1 minus x squared. But this is not the same form. This is not 1 minus x squared. It's 1 minus 4x squared. And the numbers make a difference. If there was some number multiplied on, like over here, this 1/7, that can be factored out of the entire thing. But this 4 can't. We can't just pull the 4 out. That 1 is kind of stuck there. It's part of the form. That's good. The 4 is not part of our form. So we need to change this into x squared. And we can't. But we can change it into u squared. How do you change that into u squared? Well, you let u be, what do you let u be? 2x. Why? Because what's u squared? 2x times 2x is 4x squared. So what do we get? Du is the derivative of that, 2 dx. Now if I do that, Do I have my 2dx? The answer is no, I don't. I need 2. Doing the same thing I did before. There's the 2. It's been fixed. Here's my du. That's now u squared. This is the integral of, there's a 1/2 involved. I've got du on top, and I've got the square root of 1 minus u squared. Notice, I didn't just get u on the bottom or anything like that. But this form works. This is exactly the right form. Why is it exactly the right form? See, this is u and that's x. That doesn't look good. But this is u for the variable of the du. This is our variable. So the form doesn't care what these are. I could rewrite this as 1/2 times the smiley face over square root of 1 minus smiley face squared. Because the shape of the letter doesn't matter as long as it's the same letter in every place of that. Now that's big and I'm running out of space, so I'm going to, well, I'll leave that there. What is this? This is equal to 1/2, because they can pull the 1/2 out, and then the rest of it is the inverse sine. But of course, the inverse sine, the smiley face here is the same as the u. The u is that, so our final answer is 1/2 the inverse sine of 2x, and then add c. Why add c? Because again, it's an indefinite integral. See how that works? If we don't have the exact pretty form, 1 minus x squared, then we have to change out somehow. Let's do another kind of like that. This one's got more pieces to change. Hopefully you can see, if you look at this, that it's kind of very, well, not kind of, it's very much like this one. That's the form we're looking at. It looks very much like that, but there's some numbers thrown in different. Now the first bit, we can change out that 2 if we're careful. But there's a problem, because that 5 is also not right. We didn't have that problem over here. It was a 1. So that didn't change anything. But I need a 1. I can't have a 5. So what am I going to do? I'm going to factor out of this. I'm going to factor a square root of 5 out immediately. Because if I factor a square root of 5 out, what do I get? Well, if I'm dividing out by 5, I get 2/5 here. It's looking better. The square root of 5 here is not a problem, because I'll be able to pull that out at the end. But this is a problem. Before I had 4x squared. 4x squared, I thought, okay, let u be 2x. Why 2? Because 2 squared is 4. Here I've got a 2/5, so whatever I choose as my u, when I square it, I better get 2/5. So u is the square root of 2/5 times x. Why? Because when I square that, I'm going to get 2/5 x squared. So this will be u squared. It's messy, it's a little bit ugly, but it will work. And then I need a du. The du, the derivative of this, is just that number, square root of 2/5. And then I multiply by dx to be consistent. I need a square root of 2/5 right up here. So I'm going to move my integral sign over a little bit, get more room, multiply by the square root of 2/5 because I need it for the du. But if I multiply by square root of 2/5, I better divide by square root of 2/5. I realize there's a fraction on the bottom of the fraction. It'll fix out later. How does this all work? Well, this is du. This is u squared. There's this now. That's a little awkward. And we'll worry about that in just a second. So, what do I get? I have a du. I have the square root of, that's u squared, minus 1. Now I've got this x. X, we don't want to leave an x, because our new variable is u. Don't leave x's. Change everything over. What is x? Well, if you look at it, x, you could write as x is u over this. Or you could notice, in this case, u is this times this. So these two pieces together, see, I told you it would work out. Those two pieces are just a u. And we have that square root of 5. still left over. I'm going to re-emphasize that we can factor it out. Notice, a lot of it worked out. If it didn't quite work out, we'd have to multiply and discover how to turn this x into our new variable. Now, how do we finish this off? We're going to have the 1 over square root of 5. What else? There is one other big difference. This is the absolute value. The absolute value is not the same as just that, but it is if it's positive. So I'm going to say this is the secant inverse of u plus c for u greater than 0. What else? Well, u is not our original variable, so I've got to put this in there. So let me finish this off. 1 over square root of 5 times the inverse secant of square root of 2 over square root of 5 times x plus c. Or if you prefer, I'll be consistent with what I've done so far, square root of 2/5. Now it should be noted, each time so far, I've just had sort of linear changes. But I could have something where I'm actually using like an x cubed as my thing. Let's take a look at one more example related to inverse trait. I've got this. It looks like we're going to be dealing with the integral of 1 over, or dx over 1 plus x squared, which is the inverse tangent. But there's that x. There's no u substitution involved here. So that x has to, well, it's a problem. I could let u be something. But if I do, I'm still going to have to change the bottom then. So if I've got that, what do I change the bottom? Well, let's think about this. I've got that x up there for a reason. It's different. It's qualitatively different. This, although it looks kind of like this one, the x on top changes it enough. We don't have that kind of form. When you have a form that doesn't fit, and it's not just a couple of numbers thrown out like this, just a few numbers different, this is an x. X's are qualitatively different. So you should start thinking about other forms we have, like the natural log. If I let u be the entire bottom here, what sort of du do I have? I need a 2x times dx. And in this case, I need an x. But look, I have it. I do need a 2, I don't have that, but that's not a problem. Put a 2, multiply 2 on the top, multiply 2 on the bottom. Here's my du, here's my u. I have the integral of 1 over 2 du over u. So I get 1/2 the natural log of absolute value of u, plus c of course. And then u is that. And there we go. Now, this is tricky because look at it. It looked kind of like that one. Now we have more forms. When you get something like this, you have to think, what form is going to work? Sometimes your first choice is not going to be right. It's no longer, oh, there's an obvious substitution. Now there's options, and sometimes those options work, and sometimes they don't. In the next course after this one, Calc 2, some more tricks are available for fixing different kinds of options. But right now, that's all we have. We just try a couple, and if it works, it doesn't. One more here. This looks like a natural log one. It's not. The natural log integral has an x on the bottom. Not an x squared. The 2 is a big enough difference. We have to change this. This is actually a power rule. It's not the natural log. I just mentioned that because it's important. Anyway, try several of them, get better. Until next time, Dr. Jett.